Examine the following functions for continuity. So we have f of x which is equal to modulus of x. So we need to redefine. How do you redefine something like this? Well, for x less than 5, what happens? All of this will be negative value. So we'll get minus of x minus 5. Right? For x greater than or equal to 5, the behavior of modulus is that it's going to be positive for positive values. So this will not change. So this is the very first thing that we need to do. So the behavior of modulus is going to be something like this. Let me show this so that you guys can recall this. So it's something like this, right? So for negative number, it's going to flip and it's going to give positive, and for positive number, it's just going to give the same answer. So if I give an input of minus 3.62, it is going to give plus 3.62, right? So that's what it's going to do. But since in this case we have 5x minus 5, so this behavior has to start, from 5 itself, before then 0. Because if I give an input of 4.5 over here, I get an output of minus 0.5. So the function behaves this manner. So this has to be very clear. Now, so we have to discuss the continuity at 2 to 3 different spots. One is the cases will look like, first case will be less than 5, then greater than 5 at 5. So these are 3 different cases that we need to show the continuity or talk about the continuity. So we'll talk about case. Let C be less than 5 and C belong to R. Now, we have the limit f of x as x tends towards C. So since it's a polynomial expression, so we can take it in general. So we have limit minus of x minus 5 as x tends towards C. This will be minus C plus 5. It's a bit of simplification, that's it. Now, f of C in this case would be minus C minus 5, that is minus C plus 5, which is equal to limit f of x as x tends towards C. Agree? So for all the real numbers which is less than 5, I hope you guys remember this is set of real numbers. Now for all the real numbers less than 5, this is the behavior. And from this we can tell that the function is continuous for values which is less than 5. Okay. Next case, let C be greater than 5 and C belongs to R. Now we have limit f of x as x tends towards C. Here the expression will change to C x minus 5, not C, x minus 5. Well, this is on direct substitution, by the way. I forgot to mention that. We can directly substitute because the approximation is so close that we can directly write the answer. This too is on direct substitution. Now, f of C over here would be C minus 5, which is equal to limit f of x as x tends towards C in all of this region. Okay, so here too the function is continuous. So I forgot to show you guys the graph. So let me show the actual graph. So we have x minus 5. Oh my bad, this is supposed to be x minus 5 and oh no, the expression is correct, absolute of, it's correct. So this is your graph. Is it continuous throughout? Yes, it is continuous throughout. So first thing what we did was we showed in this region wherever the red dot is moving. On the left of your well, left part of your graph, left of 5, and then we are looking at right of 5. We just finished that. So all of these places it is continuous. Now at 5 is what we have to figure out. As you can see, it is continuous, but still at, let c be equal to 5, or case at c is equal to 5. Okay, anyways, so we have limit f of x as x tends to 5 minus or c minus. We can represent it either ways, not an issue. So on the left hand side we have the different expression, right? So over here the expression is different, that we need to make a note of. X minus 5, okay, minus of x minus 5 actually, limit minus of x minus 5, x tending to 5 from the left hand side, the left hand limit. So on substitution we will get 5 minus 5, which is equal to 0. Direct substitution. Then we have the right hand limit. So this would be limit x minus 5, x tending towards 5, and on substitution we'll get 5 minus 5, which is equal to 0. And f of 0, or in this case, sorry, f of 5, at 5 the behavior is x minus 5. So this would be 5 minus 5, which would be 0. So all in all, what can we infer? Thus function is continuous throughout. Again, there are many ways of expressing your answer. So yeah.